Stars are born when massive clouds of gas collapse under their own gravity. This is how our Sun formed some 4.6 billion years ago, and it's still happening today. In fact, there are thousands of baby stars out there that are just waiting for us to find them. But it's not easy. These babies are swaddled in the warm glow of their cocooning nebula, which hides them from our view. But if we can find these newborn stars, they might help us understand what led to the formation of our Sun and planets, and with over 100 billion Earth-like planets out there in the Milky Way, chances are good that some of them might be hospitable to life. We may even have our cosmic neighbors. So the search is on, and we're going to tell you how astronomers are finding the first light of new stars. If you ever gazed up at the night sky and wondered how the universe began, you're not alone. For millennia, humans have looked up at the stars and dreamed of a beginning. Some cultures believed the world was created from a giant egg. Others thought all things were born of the first mountain. But no matter what we think about how it began, we know for a fact that stars like our Sun form from gigantic clouds of gas that collapse, and this process is still a bit of an unknown. It's like trying to take a picture of your friend's birthday party, with your friend being the flash. But instead of a flash, the massive cloud of dust is so bright, it hides the new star from view. And instead of a camera, scientists use radio telescopes to detect radiation waves emitted by molecules in space. They call this natural radio wave emissions, or what we would call spontaneous emission. And the waves they're looking for are produced by ammonia, a molecule made of 1 nitrogen and 3 hydrogen atoms. Most of the ammonia we know of here on Earth is a liquid, like the kind you put in your refrigerator when making your favorite dessert. But in space, ammonia exists as a gas. And when exposed to ultraviolet radiation from nearby hot stars, it releases energy in the form of radio waves. Now, this is important because ammonia only emits radio waves when it reaches a certain temperature, about 200 degrees Celsius. And anything that hot must be pretty close to a star. So, by identifying where in the universe ammonia is emitting radio waves, astronomers can identify areas where new stars are forming. One such place is the Orion Nebula, which lies just 1350 light-years away from Earth. It's so large that it takes up as much sky as 13 full moons lined up side by side. It's also big enough to fit 24 of our solar systems in its vast expanse. And within this nebula is a smaller cloud complex known as the Orion Molecular Cloud Complex, or OMCC for short. Within this smaller cloud, astronomers have discovered a few hundred baby stars that are just starting out. But this is only after decades of scanning the skies. And that means there could be hundreds more hidden in plain sight. To solve this problem, scientists are turning to a technique called aperture synthesis. This method combines data from multiple radio telescopes to create a virtual telescope the size of the largest array of those telescopes. And one such array is the Very Large Array, or VLA, consisting of 27 radio telescopes arranged in a Y shape across a large plot of land. When combined, the VLA acts as a single telescope about 300 feet across. With the VLA, astronomers have been mapping the positions of molecules in the OMCC by pinpointing the locations of ammonia. They've identified 6 new stellar nurseries, where baby stars are being born. These stellar nurseries are called high-mass Lie-boring cores, or HMCs, and the VLA has shown that each HMC contains multiple protostars, meaning young stars that haven't yet begun nuclear fusion. But the VLA can only detect objects that are relatively close to us. In order to see further, scientists need a telescope in space, and to the Square Kilometre Array, or SKI. Once completed, SKA will consist of 197 radio telescopes spread across 86,000 square kilometers in South Africa and Western Australia. That makes SKA the largest radio telescope in the world. When it comes online in 2024, SKA will survey the entire sky every 6 days, searching for ammonia emissions that could indicate the presence of new stars. But we'll have to wait a while to see SKA in action. For now, astronomers are still using other techniques to study the birth of stars in faraway galaxies. Take, for instance, the massive star-forming region NGC 6357, located in the southern constellation of Scorpius. This star factory is almost 52,000 light-years from Earth and spans an area twice the size of our solar system. With 10,000 stars of various ages, NGC 6357 is a rich source of information for astronomers studying stellar evolution. In 2018, an international team of astronomers analyzed data collected by NASA's Chandra X-ray Observatory and the United Kingdom's Hartree Centre used a supercomputer to model the structure of NGC 6357-Day. Their findings were published in the journal Astronomy and Astrophysics. What they discovered was a cluster of young stars surrounded by a disk of gas and dust, with pillars of material extending outwards like spokes on a wheel. The researchers believe these pillars represent massive jets of gas shooting from newly formed stars. The jets are thought to be caused by magnetic fields connecting the stars to the surrounding disk. As material from the disk falls onto the young stars, it causes a huge amount of energy to be released, which blasts outwards in all directions. These outbursts clear out lanes through the dust and gas, allowing the radiation from the stars to reach the material further out in the stellar nursery. But not all stellar nurseries are the same. Some contain stars that are several times larger than our Sun, while others produce smaller, cooler stars. The key difference between these two types of stellar nurseries is the amount of material available to form stars. For example, the Eagle Nebula is home to just under a dozen massive stars, each around 40 times heavier than our Sun, located 6,500 light-years away in the constellation of Serpens. The Eagle Nebula is actually closer to us than most stellar nurseries. But despite its proximity, astronomers know very little about it because it's enveloped in a giant wall of dust, known as the molecular cloud. 6 Soto 1. Most of what we do know comes from a paper published in 2021 by an international team of astronomers who studied the chemical properties of the Eagle Nebula. Using ALMA, an international team of astronomers mapped the distribution of water, ammonia, and methanol in the Eagle Nebula. They found that the chemistry in the nebula is divided into two regions. The inner region is dominated by water and ammonia, while the outer region is mostly methanol. Astronomers think that the water and ammonia are produced by the shock waves generated by the massive jets shooting from the young stars. The methanol is thought to come from the outer regions of the stellar nursery, where the material is less dense and more exposed to ultraviolet radiation from the stars. This division in chemistry may help astronomers better understand how different types of stellar nurseries evolve and how they produce stars of different masses. But understanding how stars form is only half the battle. The real challenge is spotting them as they're born. As we mentioned earlier, young stars are often shrouded in dust, making them difficult to observe with traditional telescopes. However, there is a way to get around this problem. All you need is a telescope that can see infrared light. For example, the Spitzer Space Telescope was designed to detect infrared light, and it's been used to discover thousands of stars that are too young to have begun nuclear fusion. One such star is V4046 Sagittarii, which lies in the constellation Sagittarius. V4046 is just 450 light-years from Earth and is one of the youngest stars ever discovered. It's estimated to be just 5,000 years old, which is practically a baby compared to our 4.6 billion-year-old Sun. To make matters even more remarkable, V4046 is still surrounded by the bulk of the material that formed it. The star is embedded in a giant sphere of gas and dust, known as a Bock globule, which is about 1,000 light-years across. This discovery suggests that stars may begin to form before their parent molecular clouds have completely broken down. In other words, the birth of a star doesn't necessarily mark the end of its stellar nursery. So while we still have a lot to learn about the birth of stars, we've come a long way since humans first gazed up at the stars and wondered how they came to be. Thanks to the work of countless astronomers over the years, we've managed to piece together a pretty good idea of how stars form and evolve. And as technology continues to improve, we'll be able to study these celestial objects in greater detail than ever before. So keep looking up, you never know what you might see. Thanks for watching this episode. If you want to support the channel, you can go to a crowdfunding platform.